Hello and welcome back to another video. Last video showed you an ESP32 talking to a Raspberry Pi with BLE. I decided to turn this into a series like I did with the Pico W. In this video I'll show you how to do bidirectional communication, and this tutorial will be accompanied by a Medium article that will link in the description. Let's get started. First we need to set things up on the Pi. Now if you've have the same setup as you did on the Pi Pico W tutorial series, then you don't need to do anything else. If not, I'll link the video here so you can reference that. But I'll give you a quick tutorial on that. You need to set up a virtual environment and then install Bleak and GPIO 0. Like I did here, my virtual environment is called Blue and I activated it with source blue bin activate. Now, if you're using the desktop version of PiOS, you're ready to go. If not, you need to install PiGPIO and enable remote GPIO. To do this, you would first do pip install PiGPIO. However, if you wanted to do a system-wide install, it would be sudo apt install PiGPIO. Then you can do sudo PiGPIO-d to get things running, which I actually have to do anyway. So we'll do sudo PiGPIO-d, and that's it. Next, on the ESP32, we will need to install AIO BLE. In this case, you can either use Thonny, you can use the Tools and Manage Package section to install it, or just copy the folder from the MicroPython lib folder. And you can see that I have the folder under the lib directory, as you can see here. I had to copy the folder because I kept getting errors on Thonny. Now in this case I can attribute it to the fact that I can't install the library system-wide without using apt. So let's take a look at some of the changes to the code. Now on the ESP32, I had to define the UIDs in their full 128 bits because it doesn't work similarly to the Pico. Now this will work on the Pico as well. It's just I couldn't use the same format that I was using on the Pico W. Everything else is still the same, although I defined pin 2 as our LED for the built-in LED. But everything else is pretty much the same except on here, where aside from defining the services, I had to put read and notify to be true, and on the write characteristic I had to do capture equals true for this to work. This is still the same. I still have the same LED task. I still have the same send data task. In fact, nothing's changed except that I added raw temperature, which comes from here, and this will give us the raw temperature of the ESP32, and it'll just send a message. It'll give us a small delay, but everything else is roughly still the same because we still have the same receive data task. And the peripheral mode is slightly different because I had to add a small delay of 100 milliseconds, but it will still advertise the same way as you can see here with our name, the interval. Now the interval is different, for at least for this case. You can change the interval to whatever you want. I gave it the name of the service, and also make sure that you have to register the service, because if you don't, it won't work. Then I have the tasks here, all three of them, and then of course remember when you send data task, you're reading it, and when you receive data, you're actually writing it. I know it's weird, but in this case it does work. And then of course we have everything else still the same, except I added a cancel error and then exception as E, and then we run the peripheral mode, but everything else still the same on here. Nothing's really changed at all. Now let's go to this code. So we're going to go to cat ESP32 two-way, and let me show you what's changed here. So aside from the usual libraries and such, I did change the MAC address of the ESP32 because I was able to find out what it is. Again, you have to reference the UUIDs fully because otherwise it won't work. We have the same blink task as we did there. And in fact, we have the same receive data. We're going to receive data here as usual. And then we have the usual send data task. And it's really simple. It's just write the character using GAT, and that's it. And then we have the connect to ESP32. This is actually very similar to the other code I used. And in fact, it's pretty much the same, just with some slight changes. So now, since this is pretty much the same, we shouldn't have to worry about this not running, as I've tested this before. So that will be it for the code setup. Let's just get to the demo now. Alright, so here is the demo. So yes, the temperature reads 130 degrees, which is expected. And of course it says hello from Central, which I've shown you from the code. So see, we are now doing bidirectional communication, and as you can see, it is updating each second. So probably one of the more challenging projects I've ever done, but definitely the more interesting ones. So I'm going to end things here. There you go, it ended by itself. So that's it for this demo. There you go. I showed you how to do bidirectional communication with the Pi and ESP32. And you notice there wasn't much change at all. And that's because BLE doesn't really care where it connects to. All it knows is that there's another device it's connecting to, and that it will either send data or receive data. Next time we'll add a potentiometer and compare the code with the Pico. Until next time.